For this problem, we're given a simple truss, and we're asked to use the method of joints to determine the force in each of the three members. And we're also asked to state whether the member is in compression or tension. So we'll start by solving for our reactions at B and C. So, of course, we know that it is an equilibrium. We know based on the type of supports at C and B, we have a vertical reaction C, and at B, we'll also have a vertical reaction. We have a force in member BC and a force in member AB, but we'll start by solving for the reactions at B and C. So we will start with some of the moments about B are equal to 0. So if we take the moments about B, we know we have 12 feet horizontally from B to A, and then another 3.75 to 15. So that's a total distance of 15.75 feet times C. So that would give us a counterclockwise moment about point B, so that is positive. And then we have our 945 pounds applied at A, which would give us a clockwise moment, so that would be negative. So we have minus 945 pounds times 12 feet. And we can solve for C. C equals 945 pounds times 12 feet divided by 15.75. And that is 720 pounds. Okay, so we solved for C. Now that we know what C is, we can solve for B. Overall, because our system is in equilibrium, we're going to set the sum of the forces in the y direction equal to 0. And that gives us B plus the 720 pounds we just solved for at C minus 945 pounds equals 0. And we know now that B equals 945 pounds minus 720 pounds, and that is 225 pounds. Okay, so we've solved for C, we've solved for B. Now we're going to look at the method of joints. So we'll look at joint B, and then we'll look at joint C. So for joint B, at joint B, let's do a quick little free body diagram here. So what we have happening at B, we have a force, B to C. We have the vertical downward force, but we also have the upwards 225 at B. So we have 225 at B. £225 pounds at B. Then we have BC. And if we were to create a force triangle, we would have a vertical, whoops, sorry, that's not too straight. Well, here we'll just, oh dear. Okay, let's do this over here. So vertical force, it's 225 pounds. It's an upward force. That is our reaction at B. So we're going to do a force triangle. And then we have the force in BC. So when we do a force triangle, the arrows touch the tails of the vectors, and so then we have our force in AB. So okay, so this is force AB. This is force BC. We know that force AB over the length, and let's do our geometry. So our vertical distance here is 9 feet. So this is 9 feet. Our horizontal distance here from B to the point where we have this load applied is 12. It's 12 feet. And then if we used Pythagorean theorem, we would find that this is 15 feet. And of course, it is a 3, 4, 5 triangle. So that said, FAB over 15 equals FBC over 12. And that all equals 225 over 9. So knowing that, we can solve for FAB. That is 375 pounds. And FBC is 300 pounds. So that was looking at joint B. Now we'll look at joint C. And again, it's the same principle. Looking at joint C, we'll create just a free body diagram. We have at C, we have that reaction. We have 720 pounds here. We have BC, or rather CA. Okay, so this is our FBC. This is our FAC. We'll do our force triangle, and again, our vertical force. Our known is our known reaction at C, our 720 pounds. Our force at BC, well, we already know what that is, don't we? But we have our force at BC. We solved for that previously. BC, this is a continuation of that member. It will be the same. All right, and then we have AC. So we now have to look at the geometry that we have here. We have the 9-foot vertical distance. So we have 9 feet. If we do Pythagorean's theorem for 9 and 3.75, we'll get 9.75 feet. So that's using 9 squared plus 3.75 squared, and then adding them and taking the hypotenuse. That gives us length AC. We already know BC, but we can confirm it this way. So let's quick do the math. So I have All right, so FBC, actually for this length, will be 3.75. Okay, so let's quick look at our ratios. So we have 720 pounds for our vertical reaction at C divided by 9 feet. And that should equal FBC, which we'll confirm, over our 3.75 feet. And that should equal our FAC over 9.75 feet. And let's quick, 720 divided by 9, that should equal 80. FBC, to check our value from earlier, would equal 80 times 3.75. And it checks out, 300 pounds, and then FAC equals 80 times 9.75. So we've solved for the forces in the members of the structure and at the reactions. And now the last part of this question is we're asked to determine whether each member is in tension or compression. So looking at our force triangles, if we look at force AB is in compression. So if we look at force BC is in tension. And then lastly, force AC is in compression.